Welcome. In this video, we're going to look at this scenario where a golf ball leaves the ground at an angle theta and hits a free while moving horizontally at height h above the ground. If the free is horizontal distance b from the point of projection, show that tan theta is equal to 2h over b, 2h over b. Then b, given that the initial velocity is 30 meters per second and theta is equal to 30 degrees. Find one, the maximum height by the golf ball, two, the range if not obstructed by the tree. So we have this diagram, then a golf ball. After hitting the golf, it leaves the ground at this angle theta and with this speed 10 meters per second. Then we're told to say the distance from this to this is b, which is simply the range. Then from this point to this point, this is the height. Now let us try to come up with this and try to see what we can do and finish this if we can. So this is what we're going to do. Let me erase the top part. The first question is to show that tan theta is equal to this, but we have got this angle, so let us try to resolve this one as we do the first part. Let us see. Then we have this. This is VO. Can you resolve this now? We know from Sokatoa that, okay, so let us say this is Vy, and let us say this is Vx. So sine theta is equal to opposite over hypotenuse. So we have opposite this, it is Vy over Vo. So Vy is equal to Vo sine theta. So this is the vertical component of the velocity. Now let us see, find also this one for cos. Cos theta is equal to adjacent, which is this one, Vx, over hypotenuse, which is Vo. So making it the subject, we are going to have Vx is equal to Vo cos theta. So this is also the horizontal component of the velocity. And okay, the horizontal component of the initial velocity. Then tan theta is equal to opposite over hypotenuse. So we have this one Vy over Vx. So this we have resolved, and we have seen from trig ratios that these are like this. So we are going to proceed. So we see that this is, let us look at the diagram now. And let us bear in mind to say, okay, let us say this is tan theta, which is equal to Vy over Vx. So from this, we see from the diagram to say the displacement that will be taken when it covers, when the golf ball comes up to this point, which is the maximum height, and coming back, it is going to cover this distance. As it goes back, as it goes up, it will cover h, and as it comes down, it is going to be 2h. So here we can say, we know that velocity, so let's say velocity in y is equal to distance over time. So the distance it is going to take from this point until this point, it is going to be 2h over t. So let us call, okay, let's call this as equation 1. Let us call this asterisk 1. Then for Vx is also equal to the distance, which is b over t. So let us call this asterisk 2. So now asterisk 1 and 2 into equation 1. We are going to have tan theta is equal to 2h over t divided by b over t. So this one can be written in this form again, times t over b. But t and t can cancel, and what we're going to have is 2h over b. So this is tan theta, and it is like this as required. Let us proceed. So this is the expression. Now we are trying to say if the initial velocity is 10 meters per second and the angle is 30 degrees, find one, the maximum height and the range. So let me erase this. So when the golf ball reaches this point is the maximum height. So when it reaches this point, the velocity will be 0. So let's say this one, h max. So at this point, it will stop going, then coming back. And this one, when it stops moving, the final velocity becomes 0. And we know that v squared is equal to u squared plus 2ax or s. But at the same time, we know that for this one, it is going to be, this is 0, this is going to be, so this is the velocity in y, since we are looking at the maximum height. So we have here vy plus 2as. Now let us plug in the value. So let us take a to be negative g, because the acceleration or the force that is acting on this golf ball is the force of gravity only. So we are going to use this value for g. So here we have, so Vy, we found it to be Vo sine theta. Okay, so this is it, Vy squared. Vy squared plus 2as, so Vy sine theta squared plus negative g. So where is s, we can put h here. So this one, we can plug in the values. We have 30 sine 30. We square this, so this will be minus 2gh. So from this one can come this side, and we're going to have 2gh is equal to, so this is 30 times 0.5, sine 30 is 0.5. This, okay, the square of this, and what we're going to have is 15 squared. So from this point, we see that 2gh is equal to 15 squared. So we can divide by 2g and also by 2g. And what we're going to have is, this one is going to give us 11.3 meters. Then we are going also to find the horizontal range. We're going to find, we are going to find this, so we can proceed as follows. So for this tree, when it is not obstructed, when the golf ball is not obstructed by the tree, we find this range. So range is equal to this one, which is Vxt. But we know that Vx is given by Vo cos theta. Okay, then t. But we do not have t. We do not have t. So we have this scenario where we know that x or h is equal to ut minus half gt squared. Displacement, when it covers the displacement from this point coming back to this one is going to be 0. And if this is equal to 0, we are going to have ut, and since it is in y, we are going to have vy t minus half gt squared. So from this point, this one can come this side, and it's going to be a positive half gt squared is equal to vy t. So I can divide by t, and also here by t, so that this square and this will cancel, and this will also cancel. And what we're going to have is gt is equal to half gt is equal to vy, which is okay times 2. This and this will go. We're going to have gt is equal to 2 vy over g, so that we remain with a t. T is equal to 2 vy over g. But vy, for vy, we found it to be vo sine theta over g. So if we plug this equation into this one, we are going to have R1 is equal to VO cos theta, then the value for t with 2 VO sine theta over g. This one can be simplified further by saying we are going to have, okay, we are going to have 2 VO squared cos theta sine theta over g. So 2 times 3. What we are going to have is